Good morning, good afternoon, and good evening, everyone. So, welcome again to this session where we will discuss on Hive Pig interview questions, and we will learn on different aspects and be prepared for interviews so that you can move into the big data arena. Here we have some list of questions and an explanation of those so that you can be well prepared for your interviews. So first of all, we will learn on Hive, which is a data warehousing package. So the question is, what are the different components of a Hive architecture? Now, when we talk about Hive, we already know that Hive is a data warehousing package, which basically allows you to work on structured data or data which can be structurized. So normally people are well versed with querying or basically processing the data using SQL queries. A lot of people come from database backgrounds and they would find it comfortable if they know structured query language. Hive is one of the data warehousing package which resides within a Hadoop ecosystem. It uses Hadoop's distributed file system to store the data, and it uses RDBMS usually to store the metadata, although metadata can be stored locally also. So what are the different components of an Hive architecture? So it has a user interface. So user interface calls the execute interface to the driver. This creates a session to the query, and then it sends the query to the compiler to generate an execution plan for it. Usually, whenever Hive is set up, it would have its metadata stored in an RDBMS. Now, to establish the connection between RDBMS and Hadoop, we need ODBC or JDBC connector jar file, and that connector jar file has a driver class. Now this driver class is mandatory to create a connection between Hive and Hadoop. So user interface creates this interface using the driver. Now we have Metastore. Metastore stores the metadata information. So any object which you create, such as database, table, indexes, their metadata is stored in Metastore, and usually this Metastore is stored in an RDBMS so that multiple users can connect to Hive. So your Metastore stores the metadata information and sends that to the compiler for execution of a query. What does the compiler do? It generates the execution plan. It has a DAG. Now DAG stands for direct acyclic graph. So it has a DAG of stages where each stage is either a metadata operation, a map or reduce job, or an operation on SDFS. And finally, we have execution engine that acts as a bridge between Hive and Hadoop to process the query. So execution engine communicates bidirectionally with Metastore to perform operations like create or drop tables. So these are four important components of Hive architecture. Now, what is the difference between external table and managed table in Hive? So we have various kinds of table in Hive, such as external table, managed table, partition table. The major difference between your managed and external table is in respect to what happens to the data if the table is dropped. Usually, whenever we create a table in Hive, it creates a managed table, or we could also call that as an internal table. Now this manages the data and moves it into warehouse directory by default. Whether you create a managed table or external table, usually the data can reside in Hive's default warehouse directory, or it could be residing in a location chosen. However, when we talk about managed table, if one drops a managed table, not only the metadata information is deleted, but the table's data is also deleted from SDFS. If we talk about external table, it is created with an external keyword explicitly, and if an external table is dropped, nothing happens to the data which resides in SDFS. So that's the main difference between your managed and external table. What might be the use case if somebody asks you? There might be a migration kind of activity, or you are interested in creating a lot of tables using your queries. So in that case, you could dump all the data on SDFS, and then you could create a table by pointing to a particular directory or multiple directories. Now you could then do some testing of your tables and would decide that you might not need all the tables. So in that case, it would be advisable to create external tables so that even if the table is later dropped, the data on SDFS will be intact unlike your managed table, where dropping of table will delete the data from SDFS also. Let's learn a little bit on partition. So what is partition in Hive and why is partitioning required in Hive? If somebody asks you that. Now, normally in world of RDBMS, partition is the process to group similar type of data together. And that is usually done on basis of a column or what we call as partitioning key. Now, each table usually has one column in context of RDBMS, which could be used to partition the data. And why do we do that? So that we can avoid scanning the complete table for a query and restrict the scan to set of data or to a particular partition. In Hive, we can have any number of partition keys. So partitioning provides granularity in Hive table. It reduces the query latency by scanning only relevant partition data instead of whole data set. We can partition at various levels. Now, if I compare RDBMS with Hive, in case of RDBMS, you could have one column which could be used for partitioning, and then you could be querying the specific partition. So in case of RDBMS, your partition column is usually a part of the table definition. So for example, if I have an employee table, I might have employee ID, employee name, employee age, and employee salary as 4 columns, and I would decide to partition the table based on salary column. Now, why would I partition it? Because I feel that employee table is growing very fast. It is, or it will have huge amount of data. And later when we query the table, we don't want to scan the complete table. So I could split my data into multiple partition based on a salary column giving some ranges. In Hive, it is a little different. In Hive, you can do partitioning, and there is a concept of static and dynamic partitioning. But in Hive, the partition column is not part of table definition. So you might have an employee table with employee ID, name, age, and that's it. That would be the table definition. But you could then have partitioning done based on salary column, which will then create a specific folder on SDFS. In that case, when we query the data, we can see the partition column also showing up. So we can partition the transaction data for a bank, for example, based on month like Jan, Feb, etc. And any operation regarding a particular month will then allow us to query that particular folder. That is where partitioning is useful. Now, why does Hive not store metadata information in SDFS if somebody asks you? So we know that Hive's data is stored in SDFS, which is Hadoop distributed file system. However, the metadata is either stored locally, and that mode of Hive would be called as embedded mode, or you could have Hive's metadata stored in RDBMS so that multiple clients can initiate a connection. Now this metadata, which is very important for Hive, would not be stored in SDFS. So we already know that SDFS read and write operations are time consuming. It is a distributed file system and it can accommodate huge amount of data. So Hive stores metadata information in metastore using RDBMS instead of SDFS. So this allows to achieve low latency and faster data access. Now, if somebody asks, what are the components used in Hive query processor? So usually we have the main components are your parser, your execution engine, logical plan generation, optimizer, and type checking. So whenever a query is submitted, it will go through a parser, and parser would check the syntax, it would check for objects which are being queried and other things to see if the query is fine. Now internally you have a semantic analyzer which will also look at the query. You have an execution engine which basically will work on the execution part. That is the best generated execution plan which could be used to get the results for the query. You could also have user-defined functions which a user would want to use, and these are normally created in Java or Java programming language, and then basically these user-defined functions are added to the class path. Now you would have a logical plan generation which basically looks at your query and then generates a logical plan or the best execution path which would be required to get to the results. Internally, there is a physical plan generated, which is then looked in by optimizer to get the best path to get to the data. And that might also be checking your different operators which you're using within your query. Finally, we would also have type checking. So these are important components in Hive. So somebody might ask you, if you are querying your data using Hive, what are the different components involved? Or if you could explain what are the different components which work when a query is submitted. So these are the components. Now, let's look a scenario based question. Suppose there are a lot of small CSV files which are present in a SDFS directory, and you want to create a single Hive table from these files. So data in these files have fields like registration number, name, email, address. So if this is what needs to be done, what will be your approach to solve it? Where will you create a single Hive table for lots of small files without degrading the performance of the system? So there can be different approaches. Now we know that there are a lot of small CSV files which are present in a directory. So we know that when we create a table in Hive, we can use a location parameter. So I could say create table, give a table name, give the column and their data types. I could specify the delimiters, and finally I could say location and then point it to a directory on SDFS. And this directory might be the directory which has a lot of CSV files. So in this case, I will avoid loading the data in the table, because table pointing to the directory will directly pick up the data from one or multiple files. And we also know that Hive does schema check on read. So it does not do a schema check on write. So in case there were one or two files which did not follow the schema of the table, it would not prevent data loading. Data would anyways be loaded. Only when you query the data, it might show you null values if data which was loaded does not follow the schema of the table. This is one approach. What is the other approach? So let's look at that. You can think about sequence file format, which is basically a smart format or a binary format, and you can group these small files together to form a sequence file. Now this could be one other smarter approach. So we could create a temporary table. So we could say create table, give a table name, give the column names and their data types. We could specify the delimiters as it shows here, that is row format, and fields terminated by. And finally, we can store that as text file. Then we can load data into this table by giving a local file system path. And then we can create a table that will store data in sequence file format. So my point 1 is storing the data in text file. Point 3 would be storing the data in sequence file format. So we say create table, give the specifications. We say row format delimited, fields are terminated by comma, stored as sequence file. Then we can move the data from test table into test sequence file table. So I could just say insert overwrite my new table as select star from other table. Remember, in Hive, you cannot do insert, update, delete. However, if the table is existing, you can do a insert overwrite from an existing table into a new table. So this could be one approach where we could have a lot of CSV files or smaller files clubbed together as one big sequence file and then store it in the table. Now, if somebody asks you, write a query to insert a new column, that is integer data type, into a Hive table, and the requirement might be that you would want to insert this table at a position before an existing column. Now that's possible by doing an alter table, giving your table name, and then specifying change column, giving your new column with the data type before an existing column. This is a simple way wherein you can insert a new column into a Hive table. What are the key differences between Hive and Pig? Now, some of you might have heard Hive is a data warehousing package and Pig is more of a scripting language. Both of them are used for data analysis, trend detection, hypothesis testing, data transformation, and many other use cases. So if we compare Hive and Pig, Hive uses a declarative language called HiveQL, that is Hive querying language, similar to SQL, and it is for reporting or for data analysis, even for data transformation or for your data extraction. Pig uses a high-level procedural language called Pig Latin, for programming. Both of them, remember, use MapReduce processing framework. So when we run a query in Hive to process the data, or when we create and submit a pig script, both of them trigger a MapReduce job unless and until we have set them to local mode. Hive operates on the server side of the cluster and basically works on structured data or data which can be structurized. Pig usually works or operates on the client side of the cluster and allows both structured, unstructured, or even I could say semi-structured data. Hive does not support Avro file format by default. However, that can be done by using the write serializer deserializer. So we can have Hive table related data stored in Avro format, in sequence file format, in Parquet format, or even as a text file format. However, when we are working on smarter formats like Avro or sequence file or Parquet, we might have to use specific serializers, deserializers. For Avro, this is the package which allows us to use Avro format. Pig supports Avro format by default. Hive was developed by Facebook and it supports partitioning, and Pig was developed by Yahoo and it does not support partitioning. So these are high level differences. There are lots and lots of differences. Remember, Hive is more of a data warehousing package and Pig is more of a scripting language or a strictly procedural flow following scripting language which allows us to process the data. Now let's get more deeper and learn about Pig, which is, as I mentioned, a scripting language which can be used for your data processing. It also uses MapReduce, although we can even have Pig run in a local mode. Let's learn about Pig in the next section. Now let's learn on some questions about Pig, which is a scripting language and it is extensively used for data processing and data analysis. So the question is, how is Apache Pig different from MapReduce? Now we all know that MapReduce is a programming model. It's quite rigid when it comes to processing the data because you have to do the mapping and reducing. You have to write huge code. Usually MapReduce is written in Java, but now it can also be written in Python. It can be written in Scala and other programming languages. So if we compare Pig with MapReduce, Pig obviously is very concise. It has less lines of code when compared to MapReduce. Now, we also know that Pig script internally will trigger a MapReduce job. However, user need not know about MapReduce programming model. They can simply write simple scripts in Pig and that will automatically be converted into MapReduce. However, MapReduce has more lines of code. Pig is high-level language which can easily perform join operations or other data processing operations. MapReduce is a low-level language which cannot perform join operations easily. So we can do join using MapReduce. However, it's not really easy in comparison to Pig. Now, as I said, on execution, every Pig operator is converted internally into a MapReduce job. So every Pig script which is run, which would be converted into MapReduce job. Now MapReduce overall is a batch oriented processing, so it takes more time to compile, it takes more time to execute, either when you run a MapReduce job or when it is triggered by Pig script. Pig works with all versions of Hadoop, and when we talk about MapReduce program, which is written in one Hadoop version, may not work with other versions. It might work or it might not. It depends on what are the dependencies, what is the compiler you're using, what programming language you have used, and what version of Hadoop you are working on. So these are the main differences between Apache Pig and MapReduce. What are the different ways of executing Pig script? So you could create a script file, store it in .pig or .text, and then you could execute it using the pig command. You could be bringing up the grunt shell, that is Pig's shell. Now that usually starts with MapReduce mode, but then we can also bring it up in a local mode, and we can also run Pig embedded as an embedded script in other programming language. So these are the different ways of executing your Pig script. Now, what are the major components of pig execution environment? This is a very common question. Interviewers would always want to know different components of Hive, different components of pig, even different components which are involved in Hadoop ecosystem. So when we want to learn about major components of pig execution environment, here are some. So you have pig scripts. Now that is written in Pig Latin using built-in operators and user-defined functions and submitted to the execution environment. That's what happens when you would want to process the data using Pig. Now there is a parser which does type checking and checks the syntax of the script. The output of parser is a DAG, direct acyclic graph. So look in Wikipedia for DAG. So DAG is basically a sequence of steps which run in one direction. Then you have an optimizer. Now this optimizer performs optimization using merge, transform, split, etc. It aims to reduce the amount of data in the pipeline. That's the whole purpose of optimizer. You have a internal compiler. So Pig compiler converts the optimized code into a MapReduce job. And here user need not know the MapReduce programming model or how it works or how it is written. They all need to know about running the Pig script, which would be internally converted into a MapReduce job. And finally, we have an execution engine. So MapReduce jobs are submitted to the execution engine to generate the desired results. So these are major components of Pig execution environment. Now, let's learn about different complex data types in Pig. Pig supports various data types. The main ones are tuple, bag, and map. What is tuple or tuple? As you might have heard, a tuple is an ordered set of fields which can contain different data types for each field. So in array, you would have multiple elements, but that would be of same types. List can also have different types. Your tuple is a collection which has different fields and each field can be of different type. Now we could have an example as 1, 3 or 1, 3, a string or a float element, and all of that form a tuple. Bag is a set of tuples. So that's represented by curly braces. So you could also imagine this like a dictionary which has various different collection elements. What is a map? Map is a set of key value pairs used to represent data. So when you work in big data field, you need to know about different data types which are supported by Pig, which are supported by Hive, which are supported in other components of Hadoop. So tuple, bag, map, array buffer. You can think about list, you can think about dictionaries, you can think about map, which is key value pair. So these are your different complex data types other than the primitive data types such as integer, character, string, boolean, float, and so on. Now, what are the various diagnostic operators available in Apache Pig? So these are some of the operators or options which you can give in a Pig script. You can do a dump. Now, dump operator runs the Pig Latin scripts and displays the result on the screen. So either I could do a dump and see the output on the screen, or I can even do a dump into and I could store my output in a particular file. So we can load the data using load operator in Pig. And then Pig also has different internal storage like JSON loader or Pig storage, which can be used if you're working on specific kind of data. And then you could do a dump either before processing or after processing, and dump would produce the result. The result could be stored in a file or seen on the screen. You also have a describe operator. Now that is used to view the schema of a relation. So you can load the data and then you can view the schema of relation using describe operator. Explain, as we might already know, displays the physical, logical, and MapReduce execution plans. So normally in RDBMS, when we use explain, we would like to see what happens behind the scenes when a particular script or a query runs. So we could load the data using load operator as in any other case. And if we would want to display the logical, physical, and MapReduce execution plans, we could use explain operator. There is also an illustrate operator. Now that gives the step-by-step execution of sequence of statements. So sometimes when we would want to analyze our script to see how good or bad they are, or would that really serve our purpose, we could use illustrate. And again, you can test that by loading the data using load operator, and you could just use a illustrate operator to have a look at the step-by-step execution of the sequence of statements which you would want to execute. So these are different diagnostic operators available in Apache Pig. Now, if somebody asks, state the usage of group, order by, and distinct keywords in Pig script. So as I said, Pig is a scripting language. So you could use various operators. So group basically collects various records with the same key and groups the data in one or more relations. Here is an example. You could do a group data. So that is basically a variable, or you can give some other name and you can say group relation name by age. Now say I have a file where I have various fields, and one of the field is relation name. So I could group that by a different field. Order by is used to display the contents of relation in a sorted order, whether ascending or descending. So I could create a variable called relation2, and then I could say order relation name 1 by ascending or descending order. Distinct basically removes the duplicate records, and it is implemented only on entire records, not on individual records. So if you would want to find out the distinct values and relation name field, I could use distinct. What are the relational operators in Pig? So you have various relational operators which help data scientists or data analysts or developers who are analyzing the data, such as co-group, which joins two or more tables and then performs group operation on the join table result. You have cross. It is used to compute the cross product, that is a Cartesian product of two or more relations. For each is basically to do some iteration. So if it will iterate through tuples of a relation, generating a data transformation. So for example, if I say variable A equals, and then I load a file in A, and then I could create a variable called B, where I could say for each A, I would want to do something, say group. Join is to join two or more tables in a relation. Limit is to limit the number of output tuples or output results. Split is to split the relation into two or more relations. Union is to get a combination, it will merge the contents of two or more relations. And order is to get a sorted result. So these are some relational operators which are extensively used in Pig for analysis. What is the use of having filters in Apache Pig? Now, say for example, I have some data which has three fields: year, product, quantity, and this is my phone sales data. So filter operator could be used to select the required values from a relation based on a condition. It also allows you to remove unwanted records from data file. So for example, filter the products where quantity is greater than 1000. So I see that I have one row wherein, or multiple rows where the quantity is greater than 1000, such as 1500, 1700, 1200. So I could create a variable called A. I would load my file using Pig storage. As I explained earlier, Pig storage is an internal parameter which can be used to specify the delimiters. Now here my delimiter is comma. So I could say using Pig storage as, and then I could specify the data type for each field. So year being integer, product being character array, and quantity being integer. Then B, I could say filter A, whatever we have in A, by quantity greater than 1000. So it's very concise, it's very simple, and it allows us to extract and process data in a simpler way. Now, suppose there is a file called test.txt having 150 records in SDFS. So this is a file which is stored on SDFS, and it has 150 records, where we can consider every record being one line. And if somebody asks you to write a pig command to retrieve the first 10 records of the file, first we will have to load the data. So I could create a variable called test_data, and I would say load my file using Pig storage, specifying the delimiter as comma as, and then I could specify my fields, whatever fields our file have. And then I would want to get only 10 records, for which I could use the limit operator. So I could say limit on test data and give me 10 records. This is very simple, and we can extract 10 records from 150 records which are stored in the file on SDFS. Now, we have learned on Pig, we have learned some questions on Hive. You could always look more in books like Programming in Hive or Programming in Pig and look for some more examples and try out these examples on a existing Hadoop setup. So here we have learned on some important questions on your Hive, which is a data warehousing package, and Pig, which is a scripting language used for data processing and analysis. Thank you and keep learning.